Good morning, everyone. In today's class, we'll be starting a new subject, which is grade 10 math. We'll start off with Unit 1, and Unit 1 will talk about linear systems. So to break down the unit, the first part is that we will take a small amount of time to review grade 9 linear relations. We'll go over graphing, slope, and the y-intercept. The second part of the unit, we'll look into linear systems. What is a linear system? Where are they being used? And the benefits of linear systems. The third part is solving linear system. We'll look at different ways to solve a linear systems, such as graphing, substitution, and elimination. So to start off with the grade 9 review of linear relations, a linear relation can be represented in three types of forms. It can be represented as an equation. For example, we can say y equals 3x plus 1. This represents a linear line. It represents a line in linear relationship. Another way of expressing it is a table of values, which, if you've seen before in grade 9, looks like this. A column for the x and a column for the y. And it's basically, we're entering numbers here for x, which is, let's say, for example, 1, 2, and 3. So we're entering that number here. For example, let's enter 1, and we'll get a value of y. So if we say 3 times 1 plus 1, that will be 4. So a y value of 4. Then if we enter 2, it will be a y value of 7 and a y value of 9. Okay, so that's what a table of value looks like. We'll go into depth later on in the course. And then the final way of representing a linear relationship is graphing. So basically taking that data that we got from a table of values and graphing it, which looks like this. Okay, these are the three different ways to express a linear relationship. You can go from an equation to a table, and from a table to a graph. Now, there's not a particular order on how to go from one form to another. You can go vice versa, from a graph to a table, and from a table to an equation. And you can go from an equation straight to a graph, and vice versa, a graph straight to an equation. So there's not a particular order on how to go from one form to another. You just have to maneuver your way through it. Okay, now let's go and look at the equation of a line. An equation of a line can be given in two forms. It can be given in slope and y-intercept form, which is the most common, which is called y equals mx plus b. And the reason it's called a slope and y-intercept form, it's because the equation is formatted in a way where the y-intercept and the slope are visible, right? That's why it's called a slope and y-intercept form, or in other words, it's called the y equals mx plus b. That's the first form of a line. Okay, now looking at at the slope, which is the slope, there's four types of slopes. There's a positive slope, where the line is increasing upward, elevating upwards. That's a positive slope. The second form is a negative slope, where the line is deviating downwards. Okay, now there is a horizontal slope which looks like this, and lastly there is a vertical slope which looks like this. Now in terms of the y-intercept, that is your y-intercept. Okay, the y-intercept is basically where the line crosses the y-axis. So this is the y-axis, and where the line crosses the y-axis, that's your y-intercept. So that is the y-axis here, the y-intercept is here. Same to this form. So let me put it in red. The y-intercept for this example is right here. For this example, that's the y-intercept, and for this example, that is the y-intercept. Now for a vertical, it does not have a y-intercept because it does not, the line is in parallel with the y-axis. Now there are special cases where the line goes over the y-intercept here, and for that case, that's a special case, and we'll see it later on in the course. Now the second form of, or the second equation of a line, the second form of an equation of a line is standard form. And standard form is given as ax plus by plus c equals 0. So you might get an example like this: 3x plus 4y equals 0. Okay? Now, you can always work your way from standard form to y equals mx plus b form, and vice versa. You just need to maneuver. The reason why we use standard form, it's not as common as the y equals mx plus b, but the reason we use it is because sometimes the y equals mx plus b form isn't as efficient, and we have to use standard form, and that's why we maneuver from one form to the other. Now, when working with a standard form, there are certain rules that need to be met. Okay? The first rule is that a, b, and c must be integers. So in this case here, I forgot to mention that in this example here, that 3 will be your a, 4 will be your b, and c will be 0 in this case. But just for the sake of this example, let's fix that. So 4y plus 5 equals 0. Therefore, c will equal 5. Now, your a, b, and c, which are these numbers here or these numbers here, need to be whole numbers. So they cannot be decimals or fractions. They have to be whole numbers. That's the coefficient a, b, and c. Okay, that's the first rule, integers. The second rule is a needs to be positive This a here needs to be positive. And the third rule is that a and b cannot be 0 at the same time. So this is ax plus by plus c equals 0. That's standard form, right? If a and b are both 0 at the same time, for example, if we say 0x plus 0 y plus 5 equals 0, this will cancel, that will cancel. You'll be left with 5 equals 0, which does not make sense, right? So you can't have a and b cannot equal 0 at the same time. Now, a can be 0 while b is a whole number. So for example, you can have something like 2y plus 5, which is your c, equals 0. Or 3x plus 2, which is the c, that's your c, equals 0. So in this case, a was 0 and b equal 2. That's acceptable. In this case, a was 3 and b equaled 0. That's acceptable. But you can't have both a and b as zeros at the same time. So that's it for y equals mx plus b form, the two forms of a line, and the standard form. See you in the next video.